Hello again and welcome back to another FMOD and Unity tutorial where today we're going to be looking at first-person footsteps once again. This time it will be using scripts that have been completely updated and redesigned for both the latest version of FMOD and Unity, which at the time of making this video is FMOD version 2.0.02 and Unity 2019.3.0A8. What I've done is I've gone ahead and created a few scripts that you can add to first-person controllers, which will allow you to play FMOD events in your game for both footstep sounds and jumping and landing sounds. So if you're interested in just using the script or downloading any of the resources you'll see in this video, I'll have links to all of that underneath this video, so go check them out. But if you're interested in learning how to use them and even how they work, then you're going to want to stick around and check this out. So before we take a look at the scripts themselves, let me quickly demonstrate this scene I've created and give you a little taster as to how the scripts work in Unity. Now in my FMOD project, which I'm going to show you in a little bit, I've got footstep sounds for 5 different materials. I've got earth, wood, stone, puddle sounds and grass sounds. So what I've done is I've created a scene with areas to represent each of those material types. So what I'm going to do is play you the scene and demonstrate what they sound like. So starting off, my player is in the area for the puddle sounds. So if I start walking around, you hear puddle footsteps. If I then walk over to stone, you hear stone, earth, grass, and then if I come up here, you hear wood sounds as well. Now for each of these materials I have 2 sets of footstep audio files. I've got one for when the player's walking and for one when the player's running. So if I start running now by holding shift, you can hear running sounds for all the different materials. I can also jump onto and off of any material, and I hear the material sound as I jump. I can also jump from one material and land onto the other and hear both material sounds. And that's pretty much all the different sounds that these scripts will play. So let's take a look at these scripts now. So the first script I created is called FMOD Studio First Person Footsteps, and this script simply attaches to your first person controller. The one I'm using is the one that comes with the standard assets pack that you can download for free from the Unity Asset Store, but I've designed this script and the other 2 I'm going to show you in a way that I'm hoping you can use with nearly any first-person controller. As you can see here, the script is designed so that you can interact with it through the Unity Inspector tab. So let's quickly take a look at the different fields that you can interact with. The first 2 are simply there for you to select which FMOD events you want. So there's one for the footsteps event you'll be playing and one for a jumping and landing event. Next there's a section which allows you to enter the names of the FMOD parameters you've created in order to control the materials that the player can walk across, the speed that controls how fast the player is moving and which footsteps to play according to that speed, and a parameter that allows you to check whether or not the player should be hearing a jumping sound or a landing sound. These are the names of my 3 parameters, but I'm going to show you them in more detail in FMOD later on. Next is the Playback Settings section, and here are just some fields that you can adjust so that the sounds play appropriately in your game. First section is called Step Distance, and this allows you to set a distance which determines how long it will take a player to hear a footstep in between. So if I change this from 2 to 8 and then play our game, and then start walking around, it takes longer for us to hear our footsteps because the player now has to travel a longer distance in order to trigger one. The next field allows you to set a length of distance that a raycast that we're using can travel. So this is something we'll talk about in more detail later on, but to give you a quick idea of how this script works, it's firing a raycast down from where the player is into the ground and then using that to check what material they're on top of. So depending on the different size of your first person controller, you can change how far this raycast travels for. If I zoom into the scene tab here, you can actually see how far mine travels. So this blue line here is representing my raycast, and if I scroll down underneath the ground, you can see it just about penetrates the ground. Now what I can do is I can change this number and the raycast will increase or shrink in length. But for now I'm just going to leave that as 1.5 as that works perfectly for my controller. The next field allows you to set a time threshold. Now remember, the way this script works is that it plays footstep sounds depending on how far the player has travelled. Well, if the player travels that distance in a certain amount of time or less, you'll then start to hear the running footstep sounds as the script knows the player is likely to be running. So this section here allows you to set that time so that you can use this script on a first-person controller that might be slower or faster than the one I'm using. So in my case, I've set mine to 0.3 seconds. So if my first-person controller is moving so fast that it takes less than 0.3 seconds for it to play a footstep, the script knows that the player is likely running and therefore starts playing the running footstep sounds instead of the walking ones. The next section allows you to enter the name of the input axis that controls the jumping in your game. Now you can find this name by going to Edit, Project Settings, and then selecting Input Manager. This is where you can select which buttons or keys that the player can interact with in order to play the game. Now here we have a section called Jump with the spacebar registered to activate it. And this is the button my first person controller checks for in order to make the player jump. So all I had to do is tell it to check for when this spacebar is pressed by checking for the jump input manager. So if for some reason in your game you're not using jump and you have a different one of these selected, you can just change the name here and it will check for when the button's pressed. For example, if you typed fire 1 here instead, it would check to see when the left control button is pressed in order to play the jump sounds. Next we have a public array of strings, and this allows you to set how many materials there are in your game for your player to walk on. Now when I show you FMOD in a little bit, you will see that I have footstep files for each of these materials. So what I've done is I've basically copied the name of each material and made sure that their element value matches up with the value they've been set in FMOD, which again I'll show you shortly. So all you have to do when interacting with this script is change the size of the material type. So if you have more materials, you might put a higher number, and then write the name of each material that corresponds with the value it's been given in FMOD. The last section we have is called Set Default Material As, and this allows you to pick a default material to play from the materials you've set in the material type section. And this is in case the player walks across the surface that you haven't marked in your game as a material. It's also there in case the raycast, for whatever reason, can't find the material it's on top of. Now the reason why this script knows which material we're on top of is because each of these objects have been assigned another script, and this one is called FMOD Studio Material Setter. From here you can simply open up a drop down menu and select which material you'd like to set the object to. Now what's really clever about this is that if we go back to our first person controller and change some of these materials, so let's change earth to glass for example, we can click on one of our objects, open up our drop down menu, and you can see it's already updated to glass. If I go back to the first person controller and check the drop down menu for the set default material value, you can also see it's changed to glass. Now this is something another script is actually doing, which I'm going to talk about later on in this video. That script is called the FMOD Studio Footsteps Editor, and it's very important that when you use this script you have it inside a folder called Editor. This is because this script makes edits specifically to the Unity editor, and if you don't have it in a folder called Editor, when you build your game, your Unity project might throw you some errors saying it doesn't recognize that script. That's because it's been designed to be used inside the editor specifically and not the game itself. So by putting it in a folder called Editor, Unity knows not to include it in the final build. The last thing I want to mention before we move on is that the way this script is able to recognize these objects is because they all have colliders attached to them. Now sometimes in your game your player might be walking on a surface that doesn't have a collider attached to it, but you'd still expect to hear the material from it. Now in this case that would be the wooden panels you see up here. Now as a game object this is designed to not collide with the player, however we'd still expect to hear wooden footsteps when walking on top of it. So the way we fix that is we click on the object and we add it a collider anyway. This allows our scripts to recognize it and change materials appropriately, but the way we make sure it doesn't collide with the player is by adding it to a different layer. As you can see here, I've created one called Don't Collide, and this is going to be for any objects that I don't want to collide with anything else. Now for you to create your own layer, you just simply click on the layer section on your object, click add layer, and then you can type in a name for a new layer. So for example, I could give a name to user layer 9. You then go back to your object and you simply assign it, as I've done here. Then to make sure it can't collide with anything, you need to go to Edit, Project Settings, Physics, and then you want to scroll down here to the Layer Collision Matrix. This is where you can decide which objects of the layers they're assigned to can collide with other layers. Now, as you can see here, this column here represents all of the objects assigned to the Don't Collide layer. And as you can see, all of the boxes for all the other layers I've unticked. So now any objects inside the Don't Collide layer won't collide with any of the objects inside any of the other layers. Now, of course, all the other objects in this scene you can see do have colliders attached to them and are also set to a different layer. This is because we obviously want the player to be able to collide with them so that they don't fall through the ground. Okay, so to quickly summarize how this works, you attach the first-person Footstep scripts to your first-person controller, you edit all the settings inside of it, you then attach all the surfaces that the player can walk on with the FMOD Studio material setter, and then you set a material for each of those surfaces. You also make sure you keep the FMOD Studio Footsteps editor script inside a folder called editor inside your assets. Okay, so now let's look at everything in a little more detail, starting with the events inside of FMOD. Okay, so the way this works is that I've created two tracks, one for footsteps for walking and one for running footsteps. I've then also created a labeled parameter called material, which holds all of the different audio files for each material. I then have a second labeled parameter called speed switch, and this controls which track you hear. So if it's set to walking, the walking track is automated to be at 0 dB, but if it's set to running, the walking track is turned down and the running track is turned up. So depending on which settings these two parameters are at will determine which footsteps you hear. So for example, if I set material to grass and speed switch to walking, we hear the sound of the player walking on grass. But I can then switch material to puddle and speed switch to running, and we hear a louder footstep on a puddle. So each section here, as you can see, has a multi-instrument inside of them. And then inside each multi-instrument is all of the footsteps for that material and speed type. And every time the multi-instrument is triggered, one of these will randomly play. Now in the description, I will have links for you to download all of these assets for you to try out yourselves, but please note that these footsteps came with the 3D game kits that you could download from the Unity's asset store. So whilst you can use them to mess around and test out this project yourself, I wouldn't recommend using them for an actual commercial project if that's what you're working on. The only footsteps that didn't come from the 3D game kit are these wooden ones here that I recorded myself, but they're a little bit rubbish, so I wouldn't blame you if you didn't want to use them. Now, if we right click on one of these parameters, we can take a better look at them. So as you can see, like I said, this is a labeled parameter type. What a labeled parameter does is allows you to set names to each of the values of your parameter, which just makes it a bit easier when working with something like this. So we can visually see which material we've set our parameter to. Each label still has a value though, and if we scroll down, you can actually see the values associated with each label. Now for this to work, it's very important that you check which label has which value, and then in Unity on your first person controller, make sure they match up with each element number. So for example, in my FMOD project, grass is the value of 2, so I've made sure it's set to element 2 in Unity. To add another label, you simply click the add button, and you can remove one by selecting one and clicking remove. If you want to change the name of one, you just double click it and then type the name you wish to enter. The initial value of this parameter doesn't actually matter too much, so you can just set yours to whichever you like. I've just left mine as the first value, which is Earth. If we scroll down a little bit, you can see that I've set the parameter scope to local. Now, whilst my parameter is set to local, it might actually make more sense to set it to global. Global simply means that whenever you use this parameter on all of the events and then switch its value in Unity, that value will be changed for all of the events that the parameter is assigned to. Now this would make sense for this project because the jump and land event, which I'm going to show you in a bit, also uses the material parameter. We also know that both events need to be set to the same material type at once, seeing as there's only one player in our game on one surface at a time. However, simply because I'm not too sure how to implement global parameters just yet into C#, I've decided to keep mine as local, and it still works just as well. The final thing I've done to this parameter is set its hold value during playback to true. Now this simply means that if this event is played and one of our audio files for our footsteps starts to play, it can't be told to stop or be interrupted if the event's told to play again. And this is simply to make sure that when crossing from one material to another, a footstep isn't interrupted to play a different material type. The speed switch parameter is pretty much the same as the material parameter. It's labeled and has its own labels. Its initial value is its first one, it's local, and we're also holding its value during the playback of the event. One last thing before we move on, in case you don't know how to set automation to a track volume based on a parameter's value, you simply right click the volume dial and you select add automation. Because I've already added it, I don't have that option, I instead have remove automation. You'll then get a drop down tab and you'll be able to assign which value of the volume you'd like to set it to when the parameter's at a specific value. Moving on, let's look at the jump and the landing event. Now it works in a similar way to the footstep event. Depending on which material you set will determine which material you hear. Again, it's using the same parameter. And we also have a parameter to control which track you hear. So if the parameter is set to jump, you hear this track here, the jump track. But if it's set to land, you hear the land track. And the difference is this event has 2 extra audio files in the timeline. So if it's played and the jump or land parameter is set to jump, you'll hear this file. But if it's set to land, you'll hear this file instead. Now the reason why I've done this is because these files are pretty bland and they're just generic jump and landing sounds. They don't have any material sounds to them. So what I've done is I've combined them with the footstep sounds of each material. So these multi-instruments just hold running footsteps for each material, and that's on both the jump sound and the landing sound. Now if alternatively you've recorded independent jumping and landing sounds for each material, you could simply not include any files in the timeline and just replace these footstep instruments here with those jump sounds. So for example, this multi-instrument would instead be filled with audio files of someone jumping off of earth. This one would be filled with audio files of someone jumping off of stone. This one here might be filled with audio files of someone landing on grass, and so on. So if that's the kind of audio files you've recorded, you can simply do that, and the event will still work. So if I set the material to stone, and then keep my jump or land parameter at land, and play it, we hear the sound of the player landing on stone. I can then change material to wood, and change this to jump. We hear the sound of them jumping off of wood. And then the jump or land parameter is exactly the same as the speed switch parameter. And that's pretty much everything on the FMOD side of things. So what we'll do now is we'll open up the FMOD Studio first person footsteps and take a look at how it was made. Okay, so the first thing we're going to look at is the variables I've created that this script uses. This top section here is all the serialized variables that you can find in Unity here, and underneath is a list of private variables, most of which are kept constant throughout the script. Now I'm not going to talk about these too much as we've just talked about how they work in Unity. The one I will point out though is this one here, this public integer called default material value that I'm actually hiding in the inspector. Now the value of this variable is actually set by the footsteps editor script, which we'll talk about a little later on. Now these 3 variables here are used to check when the player should be taking a step. Step random will hold a number randomly selected between 0 and 0.5, which we'll do later on. Previous position will keep track of where our player was in our game world and the coordinates that they were on during the last frame, and distance travelled will be used by us to measure how far the player has travelled since they last took a step. Underneath we have a private raycast hit variable type called hit, and this is what our raycasts will be using to store information on the objects they collide with. So for example, when a raycast hits an object and discovers its material, we'll be able to access that material through this variable first. Once our raycast discovers which material we're on top of, this variable will be given a value which we'll send to our FMOD parameters material, which will then change the parameter type depending on the value given. So for example, if it was given the value of 1, it would be stone, as remember that was the value that we gave to stone, 1. Underneath that we have 2 Boolean variables. These will basically tell us whether or not the player is currently touching the ground and whether or not they were touching the ground during the last frame. We'll be using both of these to help detect when we should be playing our jumping sound. Next we have a float variable, which we'll basically be using as a timer. This will hold the time since the player last took a step. And finally we have another integer variable that will tell our parameter in FMOD, the speed switch parameter, whether or not it should be set to walking or running. So if that variable is set to 0, it will be walking, but if it's set to 1, it will be running. So with the variables looked at, let's now take a look at some of the functions. Now the first method or function is the start function, and this, as we know, is played on the very first frame that the game is run. The first thing we do is assign a random value to the step random variable. We do this by accessing the random class and then the range method. We then give it a minimum number and a maximum number, and this allows it to pick a random number between that range. Later on we'll be using this to give a little variation to our steps. We then give our previous position variable a set of coordinates based on where our player currently is at the start of the game. So we do that by accessing the transform component attached to our game object and its position coordinates. So pretty simple stuff in the first frame. Now if we scroll down, we can have a look at what's happening in the update function, which, as we know, happens every frame that's run. Now the first thing we do is use the debug.drawRay function, and this will draw our blue line we saw earlier into our scene tab, and will then represent any ray casts that we cast later on in this script for us to see in our game. So the way it works is we feed it a start position, which for us is where the player is. So again, we use transform.position. Then we give it a direction in the form of a vector. So I'm using the vector3.down shortcut. We then multiply that vector by a number to tell the ray how far it's going to be traveling down. And for that, we use the ray distance number that we assigned inside of our Unity Inspector tab, which is here. And then finally, we assign it a color, which I decided to assign as blue. So here we have the first section of our update function, and this is basically checking to see if the player is touching the ground or not, and whether or not we should be playing our jump or landing sound. The first thing we do is run a method or function called groundedCheck, and this is one that was created inside of this script. It's this one here. So let's quickly open it up and see what it does. So the first thing it does is it casts a raycast. It takes the location of where our player is in the game currently. It then sends it down towards the ground, again using the vector3.down shortcut. We then output any information it collects from whatever it collides with into the hit variable we created earlier of the type raycast hit. And we also tell it to travel for a certain length, which again we use the ray distance variable for. So once we've cast our raycast, we then want to check to see if it's hit anything. If it did, then we want to set the player touching variable to true, and if it didn't, we want to set it to false. So we use an if and else statement to calculate that. So if the raycast hit variable interacts with an object that has a collider component attached to it, we want to set the player touching ground variable to true. Else, if it's not touching anything, then we want to set it to false, as this means the player must be in the air currently. So now with this function running every frame, we can check our player touching ground variable to see if we're on the ground or not. So let's go back up to our update function. So now that we can tell whether the player is touching the ground or not, we use an if statement to check to see if both the player is touching the ground and if the player has pressed the jump button. We do this by using the input class and then using the getButtonDown function. All we have to do then is feed it the name of the button that we're checking. Now remember, for us it's the button assigned to jump, which we entered into the jump input name variable inside of Unity's inspector window. So if both of those things are true, we'll then use the material check function to check what material we're on top on, and use the play, jump, or land function to play a jumping sound. First, let's take a look at the material check function, which if we scroll down, we can find here. So the first thing we do is we cast the exact same raycast we did in the grounded check function, but this time we do it inside of an if statement, so that if the raycast doesn't find anything, we can use the else statement to set the f_material value variable to whatever value we've assigned the default material value variable to. So this means that if we need to access a material and call this function, but the raycast couldn't find a material or an object that has our FMOD Studio material setter script attached to, we'll be setting our material to the default value we selected in Unity, which we set here. For example, these footsteps here, I've deliberately not added the FMOD Studio material setter script to. These are here to represent any objects you may have not added the script to in your game, or just surfaces that you're not sure which material to add to, so maybe you just want to give them the default material. Now, if I click on the first person controller, you can see I've set the default material to stone. So let's play the game and see what happens when I walk across them. So if I cross over to the earth section and then walk across the steps, so you hear me take earth footsteps, but then as I walk across the steps, you hear the stone footsteps. Now, whilst it may seem that this drop-down menu here, set default material as, is controlling our default material value variable, it's actually not, and our other script, the FMOD Studio Footsteps editor that we looked at earlier inside of the editor folder, that's what's both creating our drop-down menu in our inspector tab and also assigning a value to this variable. So we'll be looking at that later on. But either way, this variable here is now given a value for the play footsteps and the play jump or land function to use, which we'll look at later on. So if, however, the raycast does find an object to collide with, we then use another if statement. This time we want to check to see if the object it's collided with has our FMOD Studio material setter component attached. So by using the hit variable again, we check to see if it has a collider and if the game object has that component attached by using getComponent. So if our raycast hits an object with our script attached to it, we need to find out which material value that game object has been set to, so that we can then set the f_material value variable to match it. Now if we take a look inside the script, we'll see that it contains a single integer variable called material value. Remember that each one of our materials has its own value, and this variable will hold that value. So this is what our raycast needs to access. Now, just like with the default material value variable inside our first person footsteps script, this variable here is not the same as the selection of strings we can select on the FMOD Studio material setter scripts that are attached to all of our surfaces. They're two separate entities that are again handled by the FMOD Studio Footsteps editor script that we have in our editor folder. Again, we'll be looking at that later on. But for now, all you need to know is that whichever material we set on each of our objects, the value of it will be stored inside of this variable. So by accessing it, we can change our parameter in FMOD. So going back to our first person footstep script, you can see the way we access it is the same way we checked for the script in the first place. We use our hit variable that our raycast is storing information from, then we access the game object through its collider component, get the component FMOD Studio material setter, and then access the public variable. And now f_material value holds the same value as material value. If, however, the object doesn't have that script attached, we'll simply set this variable to match the default material value, just like we did if the raycast can't find an object. Okay, so let's have another look back in our update function. So if the player is touching the ground and they decide to press the jump button, we'll check from which material they're standing on top of, and then we will activate the play jump or land function. And as you can see, we're going to send it the value of true into its parameter brackets as well. That's because if we take a look at the function, which again is declared inside this script, you can see that it comes with a Boolean variable called f_jump land calculation. So this is a variable we're going to use to communicate to FMOD which setting our jump or land parameters should be set to. Should it either be set to jump, which is 0, or land, which is 1? So let's open up this function and take a look at it. Now, as you can see, this function is purely designed to play our FMOD event and make sure the parameters are set in the right position. So let's break it down. First, we create an FMOD Studio event instance variable called JL, short for jump land. We then create an instance of our jumping event and we assign it to that variable. So now this variable holds an instance of this event. Next, using the attach instance to game object function, we can attach the instance of that event to our player object. This is so that we hear the jump in the same location that the player is in the game. So we give it its transform coordinates, and we also check for a rigid body component if there is one attached. So now that we've got the instance ready and we've told it it's going to be 3D, we want to set our parameter values. We do this using the new function setParameterByName, which is what you must use when using FMOD 2.0. The way it works is that you first feed it through brackets the name of your parameter, which for us to start with is the material parameter name, which we set in Unity on the first person controller script, just here. We then tell the parameter which value we want to set it to, which, as we know, the f_material value variable holds that value. So if this was set to 1, for example, the parameter would be set to stone, as stone is value 1. So next we need to set the value of our jump or land parameter. So just like last time, we use the setParameterByName function. We tell it the name of the parameter we want to change, and we also give it a number value. Now, as we know, we're using the f_jump_land calculation variable to calculate whether or not we want to set our parameter to 0 or 1 to play the jump sound or the land sound. However, the setParameterByName function won't accept a boolean. It will only accept integer or float values, numbers, instead of true or false. So to fix this, we'll use the question mark operator. Now, the question mark operator works almost identically to an if statement. It first checks a condition and then gives us a value depending on that condition. So the condition in our case is whether or not f_jump_land_calc is set to true or false. So we put that to the left of the question mark. Then to the right, we put the two potential results. If the variable is true, which in our case it is, the parameter will be set to 0, which we put on the left side of a colon. If, however, the variable is false, we'll set the parameter to 1, which we put on the right side of a colon. So again, if it's true, we set it to 0, and if it's false, we set it to 1. So the question mark operator works as a nice quick way to convert a Boolean variable into a number value. Once the event's created and all the parameters are set, we'll tell it to start and release. So once the event has stopped, we'll no longer need the instance of that event, so release will release the instance and destroy it. So this means every time we activate the play, jump, or land function, we're creating a new instance of that event for that moment in time. This prevents us from creating loads of event instances that then pile up and are not being used, which can slow down our game. So to clarify, we use the grounded check function to check whether or not the player's touching the ground. If they are, and they press jump at the same time, we then check for which material they're on top of, and then tell the play, jump, or land function to play. We also send it the true value, which goes into our f_jump_land calculation variable, and tells the event to play the jumping sound. If, however, the variable previously touching ground is false, meaning that during the last frame the player was not touching the ground, and the player touching ground variable is true, meaning that this frame they currently are, we know that that must mean they've just landed on the ground. So then what we do is check for the material that they've just landed on using material check, and then we trigger the same function to play, but this time we send the false value into our variable, which means when it comes to setting our parameter, the jump or land parameter will be set to 1 instead of 0. Finally, once that's done, we need to set the value of our previously touching ground variable to match whatever our player touching ground variable currently is. Now, for this to work, it's important that we set the value of previously touching ground at the very end of this section, and we set player touching ground at the very beginning, which is what we did in the grounded check function. So let's say it's the very first frame of our game, and the grounded check function sets player touching to true. Well, at the very end of the frame, we'll set previously touching ground to match that value, so therefore previously touching is now true. Well, when that frame ends and the next one begins, we'll again use grounded check, but this time let's say it discovers that we're not touching the ground, so it sets player touching to false. Well, the previously touching ground variable still holds the value of it from the last frame, so this is still true. This means we can use these two variables in our code, and we have one that's holding the value of us touching the ground this frame, and one holding the value from the last frame. Then, of course, once the frame ends and we no longer need the previously touching ground variable, we update it to match whatever player touching ground was at the very end. And that's everything to the first section of the update functions. Let's now have a look at the second section. Now, the very first thing we do is update the value of time taken since step. We do this by adding whatever value time.deltaTime holds to it, and we do this by writing plus equals. So in case you don't know, time.deltaTime simply holds a float value. What it does is measures the time it took the game to change from the last frame to the current frame. This is because, as most of us know, most games run on either 30 or 60 frames per second. However, that number can change and fluctuate depending on how much stuff is going on in the game. So in order to keep a consistent check on how long things have been since something's happened or since we started the game, we use time.deltaTime to hold the value of each change between frame as it happens. We can then add it to a variable, as I've done, and this will keep track of how long the game's been running for. So for example, if our game was running really slow and only 2 frames ran during a second, the value 0.5 would be added to this variable twice. If during the next second 5 frames ran, the value 0.2 would be added to it 5 times. So now we have a variable holding a time. We'll be using this a little later on to check how fast our player is moving. Next, let's look at how we'll be calculating when the player is going to hear a footstep sound. And this I've used from another script which was actually created by the FMOD developers. This is one that was shown on the video that talks about the footsteps in the Viking village demonstration. So if you want to check out that tutorial or even that script, I'll have links to all of that under this video for you. So the way it works is that every frame we calculate how far the player has travelled since the last frame, and we then add that value to the distance travelled variable. We then check to see if that variable is more than the step distance variable we set earlier in Unity, as well as the step random value combined. We then check to see if that variable is worth more than the value we set in Unity for how far the player must travel before we hear a footstep. And if it is, we play the footstep. But let's now look at that in a little bit more detail. So starting off, we need to calculate how far the player has moved since the last frame. So the first thing we do is use transform.position to get the position coordinates of where the player currently is. So let's say this is frame 2 of our game. So the start function has run and we have the position of where our player started the game of in the first frame. That's stored inside previous position, however since then the player has moved. So what we do is we use transform.position to find the coordinates of where the player now is. We then minus the coordinates of previous position from them. This gives us a new set of coordinates, or vector. We can then use the magnitude method to take those coordinates and produce us a single float value, which will tell us how far the player has travelled. Then the last thing we do is add that onto the distance travelled variable, which now holds a number. Then once distance travelled has been updated, we want to check it inside of an if statement. First we want to take the step distance value, which remember is a constant value that won't change, because we've set it inside of Unity. Ours is currently 2. We then want to add whatever value is inside of step random. Now remember, step random holds a random value between 0 and 0.5. And let's just say for simplicity that the number picked was 0. So 0 is then added to 2. Then we check to see if distance travelled is greater than 2. Now since it's only the second frame, it's likely that it's less than 2. So therefore everything inside the if statement would not be run. However, what would happen is that we would then update the previous position variable. Just like we did with previously touching ground, we update it when we no longer need it at the end of our frame. And we update it the same way we did in the start function by feeding it our current position. Then during the next frame, once the player has moved again, we can use it to compare to the player's new position. So let's say after a few frames, distance travelled now finally is greater than 2. Well, now it's time to play our footstep, but first we need to make a few checks. The first thing we do is check for which material the player is on top of using material check. We've already looked at that. Next we need to check how fast the player is moving, which we use speed check for. Now remember, each frame that's passed, a number has been valued to the time taken since step variable, which has essentially turned it into a timer tracking how long it's been since the game started. But with that in mind, let's have a look at the speed check method. So the first thing we do is we check to see if it is less than the constant start running time, which again is a value we set inside of Unity, currently set to 0.3. So if the player has taken less than 0.3 seconds to move a distance of 2, which remember is what distance travelled is set to, we're going to set the f_player running variable to 1, which we'll be using later on when we play our footstep. If not, and it's taken more than 0.3 seconds, we set it to 0. Now remember, inside of our parameter in FMOD, we go back to the Footsteps event, and the speed switch parameter. We'll remember that walking is the value of 0 and running is the value of 1. So we'll use this variable to feed either one of those values into our parameter. Then once we've got a value for that variable, we'll reset time taken since step back to 0. Once we've made our speed check, it's then time to call the play footstep function. So let's take a look at how that works. Now the first thing you see is an if statement checking to see if the player is touching the ground. Of course, we don't want to hear a footstep if the player is in the air, so if the player is on the ground, we'll then continue on to play our footstep. Just like last time, we need to create an event instance variable and store an instance of our footstep event inside of it. As you can see here, I've called mine footstep. Because it's a 3D event, we want to attach it to this game object. We do that using attach instance to game object. We feed it the variable holding our instance, the location of our player, and we check to see if the player has a rigid body component attached. Next, we need to set the values of our parameters. Again, we want to set the value of the material based on whatever value f_material value is at, which we know has just been updated as we called the material check function before the play footstep function. Next, we want to set the value of our speed check parameter, again to either 0 or 1, depending on which value we set f_player running in the speed check function. Then once everything's set up, we tell it to start, and then once it's finished playing, we release the instance. Once the footstep sound has then been played, we want to start resetting everything for the next time. So to make it feel like the player is walking a slight little difference in distance each time they hear a footstep, we now need to reset the value of step random and give it a new value. So last time it was 0, but let's say this time it's now randomly selected to 0.2. So now distance travelled must be greater than 2.2 in order for a footstep to be played. We also need to reset distance travelled back to 0 as it's currently still on 2. And of course, because we've now done everything we wanted to in this frame, we need to reset the value of previous position. And with that, that is everything to the first person footstep script. So now we're nearly finished with all of these scripts, but it's now time to look at how we collect a value for default material value, as well as the material value variable inside of our material setter. So let's have a look at the third and final script, FMOD Studio Footsteps Editor. Now this is a script that works a little bit differently from the previous two. The main difference is that it doesn't run whilst the game is being played, but rather whilst we're making changes inside of the editor. The reason why it's able to do this is because at the top of our script, instead of using the Unity engine namespace, we're using Unity Editor instead, which allows us to make changes to the editor. Now as you can see, there are not one but two classes inside of this script. Now I'm using two classes so that each of them can focus on two different scripts. The first one will be focusing on all instances of the FMOD Studio Material Setter script attached to all of our surfaces. And the second one will be focusing on the FMOD Studio First Person script attached to our player. They're able to do this thanks to the attributes added above the two classes. By writing custom editor type of, we're able to write the name of the class we want to make changes to inside of the editor specifically. So as you can see, I've written FMOD Studio Material Setter in this one, and FMOD Studio First Person Footsteps in this one. Another difference I've made to these classes is that they are deriving from the editor instead of model behavior, which is what most of the scripts that are run inside of our game usually derive from. This simply allows us to edit those scripts attached to our game objects in the editor. Okay, so let's take a look at the first class, which I've called FMOD Studio Footsteps Editor. The first thing you can see is a public function called onInspectorGUI. This function is simply run whenever we make changes inside of the editor. For example, if I go into Unity, select one of my surfaces, and then change the set material as to a different material, the function will then be run. Now you may notice this other keyword called override. Now what that's doing is basically taking everything that will be normally displayed publicly on the component in the Unity Inspector tab and removing it for us to change. Now in the case of the Studio Material Setter, that would be the public integer variable we created called material value. Because this variable is public, it would normally be displayed in Unity. We'd see the name of it and a number that we could change it to. However, because this function has been set to override, it's now removed, allowing us to add different stuff and make changes. Now, before we continue, the goal for our material setter is to add a drop-down menu for us to make edits to in the Unity inspector. We then want to take whichever material we set that drop-down menu to, take its value and store it inside of the material value variable for our Footstep script to use, which we've talked about earlier. Now, in order for us to do that, we need to store references to both of those scripts inside of variables. We need the material setter so we can make changes to the material value variable, and we need the first person footsteps one so we can use the material types public string, which remember has the names of all of our materials and which number they represent, to change that variable. So as you can see here, the first thing we do is create variables, one called ms and one called fpf, short for their names. And normally the variables would be of the type that we are referencing. So for example, in this case, FMOD Studio Material Setter, that would be the name of the type. However, instead, we can just use the keyword var. We're able to do this because we're setting the value of this variable straight away, as you can see here, and we can also do it because we're using it inside of a function. Other than that, it just makes it easier to declare the variable. So now that we've declared it, we need to assign which script we want to store a reference to inside of it. Now we're able to write target as, and then the name of the script we want to access because we've written it up here inside of our custom editor attribute. Unfortunately, because we can only use this attribute once per class, when it comes to finding a reference of the first person footsteps class, we instead have to use find object of type to reference it. But either way, it works just fine. We now have two variables referencing each class. So now that we've got them, it's time for us to create our drop-down menu. We do that by writing editor GUI layout.popup. This part here is what tells Unity to add the drop-down menu to the script inside of the inspector tab. By using editor GUI layout, we can also add other stuff to our inspector if we wanted to. If you'd like to learn more about what you can add to your scripts in the Inspector tab, I'll have a link under this video for you to check out a page on Unity which tells you all the different options you have when using Editor GUI Layout. But the way pop-up works is that we need to give it 3 arguments. The first, we need to give it a name as a string, so I've called mine setMaterialAs. This is then displayed next to the drop-down menu here. Next argument we need to give it is a value that we want to be able to change our drop-down menu to. Now don't forget, the whole point of this drop-down menu is to set the value of our material value variable inside of our material setter script. Now, as you can see, I'm setting the result of this drop-down menu whenever the drop-down menu is changed in the inspector and our function is activated to that exact variable by accessing the ms variable, holding a reference to that script, and then accessing the variable material value. Now, it might be a little bit confusing that we've added this variable twice. This part here is basically saying we want to set this variable to whatever value the drop-down menu is set to, and this part here is giving us a value that we can change the drop-down menu to. For example, if I were to change this to the value of 3 and save the script, and then go back into Unity to check out the script, I could open up the drop-down menu, but I wouldn't be able to set it to anything else other than puddle, even if I keep clicking on other options. This is because puddle in our public array of strings that we created on the first-person controller down here is the third element and is represented by the value 3. So whenever we make a change to this script inside of Unity, it doesn't matter what that change is, that value is always going to be assigned to 3. Now obviously this isn't what we want. We want our material value variable to not be set to 3, but be set to whatever material we choose when we make the change. So let's go back to our script and change that back to material value. Finally, the last argument we have to give it is a list of options for our drop-down menu. This has to be in the form of an array of strings, so we want to use our material types array. We access that through the fpf variable, which is holding a reference to our first-person footstep script. And with that, we now have a drop-down menu that will make a change to our material value variable on each of the instances of our material setter script. So now, whenever we set one of our objects to a particular material, the value of that material, depending on where it was entered in the array, will be assigned to the material value variable via our FMOD Studio Footsteps editor script and stored inside of the FMOD Studio material setter. Then once our player is walking around and using the first person footsteps script, our raycast inside of the material check function will collide with an object that has that script attached to it, take the value inside of material value, and then assign it to f_material_value. Then when a footstep is told to play by the footstep function, the material parameter will be set to that value, and then our event inside of FMOD will be given a value. So now let's take a look at the second class, which makes edits to the first person footstep script attached to the player. So just like last time, we want to use the onInspector GUI function so that we can make changes to the script in the inspector tab whenever we make changes to it. We want to override it, however, we don't want to remove all of the other fields that we set up inside of the script in C#. So the way we keep them is by using this function here, drawDefaultInspector. This essentially adds everything back to the script that we made public or serialized inside our script after the override keyword removes it all. So just like last time, we want to create a variable we'll call FPF. We want to use it to hold a reference to the script we want to make edits to, which is FMOD Studio First Person Footsteps. Next, as you can see here, we're going to create another drop-down menu. This time we're going to use it to make edits to the default material value. So as we know, we can make changes to this drop-down menu and select a material that will change our FMOD parameter to if the player is walking on a surface that either doesn't have a script attached to it or can't be found by the raycast. So the way we do that, just like last time, is first giving it a name in the form of a string. We then include an integer variable we can make changes with. So for us, it's the default material value variable that we can find inside of our footstep script here. We also then give it a list of options using a string array, which again is the material types array, again found in the same script. Then whenever we make a change in Unity and select a default material, the value of that material, so for grass would be 2, will be stored inside of default material value. Then when it comes to our material check function, if the raycast can't find our script or an object, f_material value is set to match it. And as we know, that will be used to then set a value to our parameter in FMOD. And with that, that's everything you need to know when it comes to using these scripts and adding footsteps to a first-person character. So I hope you enjoyed learning about how these scripts were made and how to use them. Now if you want any of the resources I've talked about or mentioned in this video, I'm going to try and have everything linked underneath it in the description for you to use. You should also be able to find links to my website where you'll be able to download the scripts, the FMOD project and the Unity project. Let me know if there's anything to do with FMOD or Unity you'd like me to talk about in another video. I'll be happy to check out all your suggestions in the comments section. And whilst I don't usually ask for this, give this video a like if you found this helpful, because this was a long one to make. But I've been Henry Scott, thank you very much for watching and I'll see you in another video.